Live. All right. Also, just a quick reminder, classroom policy, your phone should be off and in your backpack before you walk through my door, and it should not come out until after you have left my door. So that doesn't mean in your pocket. It means in your bag, please. And I say that in case you're wondering why. Why has Mr. Emery got a big hang up on cell phones? Guys, they're just a huge distraction. They have, and mine is sitting here because I was playing music, but since I'm not going to be playing music, I will set the example and go put it on my desk. Here's another thing that's scientific. If your phone is sitting there, even if you're not paying attention to it, it will distract you because you'll be expecting something to happen. You'll be like, oh, it might buzz, or I might get a notification that somebody's texted me or somebody's called me or something. And so just sitting there, it is actually a distraction, which is, I think, sort of interesting and unexpected. You'd think, hey, it's off, what could possibly happen? All right, guys, so let's do a little warm-up, a review of what we did a week ago. We had looked at the following equation, y equals, well, this is an example, x minus 3 squared plus, or minus 2. And here's what we had figured out with this equation. We had figured out that this was going to shift the whole parabola 3 to the right. And we had figured out that this was going to shift the whole parabola 2 down. Everybody got a pencil, writing stick? Anyone need anything? That's all good? Okay. So if we wanted to, okay, let's talk about one more thing also. The quick graph points, we had looked at this for a parabola and said that 0 squared, this is our parent, was 0. Negative 1 squared and 1 squared were both 1. And negative 2 squared and 2 squared were both 4. So if I wanted to make a quick graph, I start at 0, 0, and I go 1, 1, 2, 4. I put those 5 points on, boom, I've got my parabola. 8.5 seconds, it's like a rodeo. You graph in 8.5 seconds, you win a prize. So what we had discovered is that this pattern of 0, 1, 4 doesn't change no matter where the vertex is. And so if I was looking at this graph, 1, 2, 3, I'll put a couple more numbers on there. 1, 2, 1, 2, 3. But I could say, oh, okay, well, my vertex was 3 to the right and 2 down, so my vertex is right here. And then my quick graph pattern is 1, 2, 4. 2, 3, 4. 1, 2, 3, 4. Boom. I graphed a parabola with the equation x minus 3 squared minus 2. So, your turn. I equals x plus 1 squared minus 3. Go ahead and draw yourself a quick graph of that parabola. Identify the vertex, and then draw yourself a quick graph of that parabola. Luis, where's the vertex?
-1.
Sure.
Actually, -1, -3.
Boom. Yeah. Remember, this is always opposite. This is the confusing part. We're looking for what value of x makes that equal to 0. And if you remember, the equation is x minus h squared plus k. And so that one's opposite. And you have to sort of remember that one. You have to tuck that away. Is it, oh, wait, I'm looking for what's a 0. Good. So -1, -3. Here's my vertex. All right, next set of points, Jared. You know what? Tell me where to go. Don't even tell me what the points are. Just tell me where to go. Over 1 up 1. Boom. Over 1 up 1. Over 1 up 1. And see, that way, Jared doesn't even have to figure out what the coordinates of those points are. If you just look at your graphing paper and go, boom, boom, you're done. Cool. Amber, next set of points. Over 2 up 4. 1, 2, 1, 2, 3, 4. Boom. Here, I'll put a number there. 1, 2. Oh, better put a number there. 1, 2, 3, 4. Boom. And I have a graph of a parabola y equals x plus 1 squared minus 3. That easy. Nicely done. So here's the next question. What happens if I was asked to graph y equals 2 times x plus 1 squared minus 3? Give that a second thought and think about how you would graph that. And if you want to put it on the same set of axes, maybe with a different color or just different dashes instead of a line, think about that one. What changes? Give you a second to think about that. Hey, Xander, where's the vertex of this parabola?
It's -2, -3.
Question, does that make this equal to 0? What would make that equal to 0?
If you x was -1.
There's your vertex. Hey, guess what? The 2 didn't change the vertex. Because the vertex is still based on what makes the x equal to 0, because that's my left-right shift. My left-right shift doesn't change if I put a stretch factor out front. My left-right shift is still 1 to the left and 3 down. So my vertex is still at -1, -3. So what does the 2 tell us? What does it do to the equation? Eliana, got a thought there? So wider, define wider. So here's my regular parabola, and if I put a 2, it's going to go like this. Okay, so let's think about my equation. If I were to draw my quick graph, and Eliana, I'm going to come back to you again, because you got the right thought, but the wrong direction. If I plug in y equals 2x squared, so I've still got -2, -1, 0, 1, 2. Remember, this is my quick graph stuff, not, this is quick graph, not this parabola necessarily. So 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is what, Eliana? 1 times 2? 2 squared is 4 times 2 is what, Eliana? So if I multiply everything by 2, I don't get wider this way. I get taller, don't I? Because instead of 0, 1, 4, I got 0, 2, 8. So when I graph, I go up 2 instead of up 1. And I go up 8 instead of up 4. And there's my new parabola. So yeah, the thing in front definitely changes the shape of the parabola. But if I've got something greater than 1, then it gets taller. And if I got something less than 1, then it's going to get what Eliana called wider, but I prefer to call flatter, because we're talking vertical shift here. So what we've got here is we've got a little modification to our equation. That we have this stretch factor. And if A is greater than 1, it's called a vertical stretch. And vertical stretch means steeper. And if A is between 0 and 1, we have a vertical compression. And remember, vertical just means up or down. And that's flatter. And a really easy way to remember it is just to think, what happens to my quick graph numbers if I multiply by whatever that value is? If it's 2, they'll all get twice as big except for the 0. If it's less than 2, they'll all get smaller except for the 0. Okay? These are the numbers, of course. This is your quick graph numbers. So let's try one more, and then we will move on to the next thing. Let's try y equals 1/2 x plus 1 squared minus 3. So find the vertex, do a quick graph. Let's see what we got. Eduardo, where's the vertex?
-1,
Boom. Vertex hasn't changed. The 1/2 doesn't change that. Good. Hey, Eduardo, why don't we just have you tell me where the next points are?
Guess we have few decimals, so just kind of ignore the 1, take a little bit of 0.5. So
Oh, I'm okay with that.
that's
So over 1 up a half?
Yeah.
Okay, but a half is just right there, right? I mean, that's an easy decimal, so what the heck, why not? Where's next?
over 2.
2 and 2. Now, might it be harder if on some of these, good morning. It might be harder on some of these where you got like crazy weird decimals, but at some point you're probably going to have to deal with decimals. If I gave you 1/3, well, now the first 2 points are all decimals, but we approximate, we just put it on there. Good morning. You'll need either your notebook or some paper. There's paper back there if you don't have any. Pencil, ready to write with. I'm assuming everything went well?
Yeah.
Cool. Good to have you back. So at some point you're going to probably be dealing with decimals, but it's an approximation. You know, half. Oh, you know what? That's 1, that's a half. Okay, dot, dot. Half of 4, well, there's an easy one, as Eduardo pointed out. So, okay, that's 2. Good, dot, dot. Got everything we need. If it was a third, well, now we got a third. Okay, that's a little bit lower. And a third of 4 is, well, that's 1 1/3. So we would go up 1 and then up a little bit more. And it's okay. Because a quick graph is it's a really easy way to get a fast graph, which means it doesn't have to be 100% perfect. It just has to be as close as we can get it. And that's okay. Guys cool with that? All right. So here's the problem. This is awesome as long as we're given this equation. Super easy to graph. Let's talk about what happens when we're not given that equation. This, by the way, is called the graphing form, or sometimes called the vertex form. You will see both graphing and vertex form, and hopefully the reasons for the names are obvious. Graphing form because it's really useful for graphing, vertex form because it tells us the vertex. So those are sort of the 2 names for that form. The other form is called standard form. So standard form might look like this. Y equals 2x squared plus 4x plus 30. Now, I immediately know one thing. I immediately know that the y-intercept is at 0, 30. So if I wanted to make a graph, I could put a dot right there. That is completely useless. Because I don't know which direction it goes. I don't know where the vertex is. I don't know where the x-intercepts are. This is a completely useless piece of information at this point if my goal is to end up with a graph. Oh, look, I got a dot way up there on the y-axis. Okay, now what? I don't know. So the next step, or the first step, since this is useless, is let's find the x-intercepts. Step 1, find x-intercepts. intercepts. And I've got a couple strategies for finding x-intercepts. One strategy is factor, and another strategy is quadratic formula. There are advantages and disadvantages to both of these. The advantage of factoring is it's simpler than quadratic formula. The disadvantage of factoring is that not all quadratics factor, which means that I have to use the quadratic formula. And the disadvantage of both of these that we'll see a little bit later on is, what if I've got a parabola that doesn't have x-intercepts? Then this doesn't help me at all. But we're going to start by looking at a couple examples of quadratics that have x-intercepts. So the first thing we want to do is we always want to start with factor, because if it's a simple one, we can factor in 30 seconds to a minute, and then we don't have to go through the pain and agony of trying to do the quadratic formula right, which can be a nightmare. So let's talk about factoring. I'm going to erase quadratic formula option B for now. We might come back to it later. Anybody notice anything that immediately factors out of 2x squared plus 4x plus 30? 2. Good. I noticed that every single one of these numbers is divisible by 2. And so I'm going to do my generic rectangle factoring. You guys may remember this from algebra. If not, hey, guess what? Refresher time. 2 times what equals 2x squared? X squared. Plus 2 times what equals 4x? 2x. Plus 2 times what equals 30? 15. Hey, look, I can now write y equals 2 times x squared plus 2x plus 15. My problem just got easier. You should always be looking for, is there a common factor that I could pull out and make my problem easier? You guys may remember way back in algebra, you did ones where it was like 2000x squared plus 1000x equals 3000. And you're like, hey, well, what if we just factor out 1000 and then it's 2x squared plus x plus 3? Oh, so much easier. So same idea. Anytime you look at one of those, if you see something that'll factor out immediately, factor it out, get rid of it, move on to the next thing. Now, we're talking about x-intercepts, so we're going to want to factor this. We also remember something about, anyone remember what we know about x-intercepts? There's one little fact that makes our life easy. What do all x-intercepts have in common?
Y equals 0.
Y equals 0. So I can rewrite this as 0 equals 2 times x squared plus 2x plus 15. And here's a question. If 2 times this something equals 0, what does that tell you about the something?
0.
The 0 must be equal to the something, because the 2 can't be, right? So now I can take this a step further, and I'm going to go back up here because I've run out of paper. I know that this thing must be equal to 0. Hopefully everything I'm doing right now on the board, you're saying, oh yeah, I knew that. Oh yeah, I knew that. Or, oh yeah, I'd forgotten that, but now I remember. Because these are all refresher review type things. And we're getting to the point of why we learned all these so that we can do these more complicated problems. I'm going to erase my graph here. Give me just a second to erase this. Give myself a little bit more room and make it visually more appealing. I'll leave that there for now. I'll leave that there for now. So, next step, factor the quadratic. This is where you have a couple choices. Choice number one. Fill that out, figure out what goes into the parentheses. Choice number two. Just start thinking about what has to go into the parentheses. When I multiply these two parentheses together, and I end up with an x squared, if you think about multiplying these parentheses together, but there's an x squared, what has to go at the beginning of each parentheses? X. Automatically, x times x is going to be x squared. And remember, this is x plus something and x plus something. Here, I'm going to put the somethings. But there's going to be an x squared right there, which means that it's got to be x and x. Now, missing colors. Here we go. What do I know about that number right there? When I multiply two numbers together, what do I get? Another number, right? But the only number in here, because that's got x's, the only number in here is 15. Which means that whatever these numbers are, they have to multiply to 15. What numbers multiply to 15? 5 and 3, good. 5 times 3. What else multiplies to 15? 1 and 15. Those are my only two choices, aren't they? Assuming this factors nicely. There could be decimals, but I don't care about the decimal ones. I just want whole number ones for factoring. Now, I feel like there's something horribly wrong with this equation because this isn't going to work. Did I copy something down on my notes wrong? I did. I have, massive apologies. Get out your eraser. That's a minus 30. I copied it wrong out of my notebook. And so therefore this is a minus 30. Oh, I'm sorry. I did not mean to cause you all this work. So this is a minus 15. I was looking at that and going, wait, this isn't going to work. Oh, that's a minus 15. And this must be a negative 15 inside here. So here's the next part of this. These two are going to be either 1x and 15x, or it's going to be 5x and 3x. And one of them is going to have to be negative, agreed, to make that a negative 15. So it's negative 5, positive 3, negative 1, positive 15, positive 5, negative 3, positive 1, negative 15. And these have to add up to plus 2. Notice that we can immediately eliminate 1 and 15 because there's no way that 1 and 15 ever add up to 2. No matter how we juggle the signs, agreed? So it has to be either negative 5 and positive 3 or positive 5 and negative 3. Should we have a vote?
Positive 5 and negative 3.
All in favor of positive 5 and negative 3, raise your hands. Or signify by saying aye. Good. Plus 5, minus 3. Guys, this is what I mean by puzzle out the solution. It's actually easier. as you do more and more of these factoring quadratics, it's easier sometimes to puzzle it out than it is to draw out this whole process. Because when you look at this, you say two numbers that multiply to negative 15. Okay, well, there's my choices. But they need to add up to plus 2. Oh, look, there's my answer. And you can just stick that in and say plus 5 minus 3. Okay? Again, this is a practice thing. You get better at it as you practice. Some people will see it faster. Some people will need to do this a little bit longer. But remember, as you're going, the goal is to be looking at that pattern so that you get to the point where you can do it fairly quickly. That's sort of the objective there, is start to be thinking about, hey, am I seeing these patterns? Because when you see the patterns, you can just write them down. So my x-intercepts are at, where are my x-intercepts? I need that to be 0, which means either that must be 0 or that must be 0, which means that x is, or x is. Where's my two x-intercepts? So let's look at our graph now. Still don't know where the vertex is. Do I know anything about the vertex now that I'm looking at this graph with the two x-intercepts on it? Give that a little bit of thought. What do I know about the vertex now that I know that there's an intercept at 3 and an intercept at -5? Give you a second to think about that one. What do I know about the vertex of this parabola? Anyone want to volunteer for this one? I got one volunteer. Jared? Has to be in the middle. Guys, remember parabolas have symmetry, right? Which means that the vertex is right in the middle. There's a line of symmetry going straight up and down, exactly halfway between -5 and +3. So the question then becomes, what number is halfway between -5 and 3? And how do I calculate a number that is exactly halfway between two other numbers? I'm asking you a question that when I tell you the word, or when one of you tells us the word, you're going to be like, oh my gosh, that's so easy. But I'm asking the question in a completely different way that maybe you've never heard before. How do I find a number that is halfway between two other numbers? Justin,
Add them together, like some negative and positive.
Add them together, 5 plus -3. That gives me -2. So is that halfway between? What do you guys think? Is -2 halfway between? No? Eduardo, you're shaking your head no? What could you do to that to make it halfway? Divided by 2. Guys, what's the other word for add two numbers together and then divide them by 2? There's a word. Take our two numbers, we add them, we divide by 2. You got an 80% on one test, you got 100% on one test. You add those two scores together, you divide by 2, you've got your average. Average. That's what we're doing, is we're averaging the x-intercepts. We want to average the x-intercepts. Because I'm going to highlight that one. Got your highlighters with you? In your notes? Highlight that. Because once you know those x-intercepts, this becomes super simple. Add them together, divide by 2, which means that there must be a vertex on this line somewhere, x equals -1. So how do I find the y value? X equals -1 and y equals, do I have a relationship between x and y somewhere on this board?
2x².
Oh yeah, there it is. There's the relationship between x and y. Whatever x is, if I square it, multiply it by 2, and then multiply it by 4, and add them together and subtract 30, I will get y. So now we can calculate y equals 2 times -1 squared plus 4 times -1 minus 30. Now, this looks like a calculator thing to me, although, we could do it in our head if we were careful. What do we got to watch out for here? Remember we talked about this last week? Make sure you put that -1 in parentheses when you square it. Because if you just type in 2 times -1 squared, it will assume that you're only squaring the 1 and not the negative. So what do we got here? We got +2, we got -4, we got -30. Sounds to me like -32. And I know that the vertex is at -1, -32. And I got to be a little bit careful here because I could write the equation y equals x plus 1 squared minus 32. Is there a stretch factor on this one?
Yeah,
Dominic, what is it?
I don't know. You said be careful about it.
Good observation. Reading the crowd, yeah. Hey, looking at the original equation, what would you say the stretch factor was? 2. Yeah. Because does it make sense that if I'm multiplying the whole thing by 2, but I had a regular parabola otherwise, that maybe 2 is the stretch factor? We're going to see this a little bit later. We don't have to worry too much about it right now. But I believe that there's a 2 right there, which means that when I do my quick graph, I got a factor of 2. So I'm going to go up 2 in both directions. And then I'm going to go up 8 in both directions. So I'm at -30 here, and I'm at -24 here. Oops. And I, boom, have my quick graph. And yes, it's not really to scale because I didn't do a very good job of making my scale because I didn't want to. It was boring. Yeah, it doesn't matter. I mean, it is what it is. It's just a crummy scale, which led to a crummy graph because we know that parabolas don't have little wobbles in them. Questions? All right. Let's do, why don't you do one? And I'm going to give you one without, okay, I'm going to erase the graph because it was a crummy graph anyway. And we'll put a your turn up here. And I'm going to give you one without a stretch factor. Y equals x squared minus 10x plus 16. So I'll give you a remember, step number one is factor and find x-intercepts. Once you find the x-intercepts, go ahead and work your way through the process. Find the vertex.
Little plan I'm gonna put together for you guys each week as far as what you need to do on each day, so that there's less confusion over the classroom stuff. All right? So quick question, is there anything that factors out of all three of those? Sounds like one. Yeah, and because it's a one, you don't have to do that step. The only time you have to do this step is if there's some number out front and you notice that it goes evenly into all three of them. Otherwise, you can skip that one and say, yeah, it's already there. We've already got x squared, which is now, the next step is just the two parentheses factoring. You betcha. Did you hear my explanation to him on that part? So because you have a one there in front of the x squared, it means that there's nothing that's gonna go into all three of those equally, which means you can skip that step and go straight to the two parentheses. The only time you have to do that step is if you got a number up front. Yeah, I don't know glasses on, so I have to switch to see things. So your next step is gonna be what goes into those two parentheses.
Okay.
Yeah. So here you want to be a little bit careful. There wouldn't be an X out here because there's no X right there, right? So if you think about this factoring, if you were actually doing, can I write over here? So if you were factoring, this would really, X times Y equals X squared, you use the X, right? And then right here with your negative 10X, you have X times something equals negative 10X, that would just be a negative 10. But then when we get out to here, there's nothing that we could multiply together to make this just a plain old 16. Because it has to be X times something. And so at that point, we realized, oh, we're not even gonna do this. We're not gonna do this process. The only time we're gonna do this process is if we have a number right here. Because then we wanna get rid of that number so that the equation looks like X squared plus something. But we already have it. So we don't have to. Cool. So yeah, so we're gonna go straight to here using that equation, not this equation. Because this equation, I'll let you erase it. I want to try it off to the side. Right. So we got X minus 8X, I like it. So there's our two intercepts. So what comes next? When we know the intercept, where must the vertex be? Oh, okay. Boom.
Can you take that now and write the equation in that vertex form? You're liking taking notes, or would you feel better writing? No worries.
This
Just
way
so-
I'm not wondering what I wrote.
Makes sense. Cool.
So.
Really? So how do I find exactly in the middle of 82? Times it?
Oh,
It's the easy way. What's the word I got written on the board in red, circled in yellow? How do you average 2 and 8? Boom. Well, 2 times 1 would be 16, right? But, so let's make a little list. No, we brought a pencil. 1 times what? 16. Good. 2 times what is 16? Does 3 go in? 16? Does 4 go in? I would say that. Any of those add up to 10? So it's gotta be 2 and 8. But you want it to add up to the negative 10, so what sign is it? And? Yeah, then multiply the positive, they add them to negative. There's your factoring. That. Okay, so we're trying to factor, right? Which means we want to write this as y equals parentheses. If you remember back, way back down, we can do it that way. Put the x squared in here, put 16 in here, and we're looking for 2 numbers that multiply that. Put that up to this. So what are your 2 numbers? They can multiply this positive 16 and half. Some numbers multiply 16. So you would stop right there. Does this one have a 10? You got it first time, right? So there's other numbers that multiply to 16. As soon as you find the ones that add up to 10, you're done. So are they going to have to be negative or positive, or one of each? So if you make one of them negative, you're going to multiply to negative 16. So what are you going to write? So except one of those. Oh, you got it right. It was under your hand, so I couldn't see it. There you go. X minus 2, x minus 8. So what are your x-intercepts? What values of x make that equal to 0?
But if I put in -2 and 1.0, it's 4, right? So what do I really need to do? Instead of -2, what would you put in there to make that equal 0? And there's
Guys, we will talk about this problem tomorrow. There is no homework tonight. Okay? Next week, I might start giving a little homework assignment on one of the 2 days, probably on Wednesday. Well, actually, next week I won't because we've already talked. Next week is weird. But for now, no homework today. Tomorrow, you will have the classwork worksheet, and if you don't finish it in class, that'll be your homework, okay? Right now, you're gonna go to homeroom. Does everybody know who their homeroom teacher is and where they are supposed to go?
Homework and Thursday and Tuesday on the same class.
Bummer, man.
Yes.
Yeah, but isn't it nice to get up and walk around? Cool, guys. Thanks very much. Good job. It's nice to see you again. See you all tomorrow. Please make sure you get assignments done and turned in Google Classroom. I had a lot of incompletes last semester, and I had a lot of people scrambling at the last second to not get an incomplete. Let's make sure that doesn't happen this time around. Have an awesome day.
Wait up, dude. I know. You walking so fucking fast. I was gonna say, what are you doing up? Why? This morning. Don't hate me because I'm beautiful. I'm going up this morning. That's super early. Way too early.